So today I'm just going to show you, I'm going to kind of go over the study guide for you all. Understand that your all's test is Monday. You're looking like a 30 question multiple choice test. So take the time, kind of get familiar with the study guide here. You know, it's a lot of just kind of computation, but I'm going to go through all of the problems just so kind of a reference point to kind of really check to see if you really understood what was going on here. Okay, so the first four problems we have to evaluate each expression. So we need to simplify our numbers down to one value here. Okay, so one thing we notice with all of the parentheses, kind of the rule of thumb, start as far as the inside of the parentheses you can go, kind of branch yourselves out. So my I goes here. I've got a -8 minus a 6. -8 minus 6 is a -14. So I'm just going to rewrite all of kind of working from left to right. There's nothing we can do with this -9. I have a minus, a negative, so I'm just going to go ahead and say positive, right? When we subtract the negative, we add. And then we're subtracting everything in this parenthesis, right? There's not a lot of, there's not a lot of action going on with that -8. So -8 minus 6 is a -14. Okay, so that writing down the parentheses kind of help you see that you have a double negative there as well. So it's the same thing as we can just go ahead and add that together. So -9 plus 9 is 0. That's going to go away, but we are left with a positive 14. All right, on to number 2 there. Same thing, we've got parentheses that we've got to take care of, so I'm going to go ahead and take care of this 9 times 2. 9 times 2 is 18, divided by a -6 plus 4. So we took care of parentheses, now we're working left to right. We notice that we have a division. We definitely need to take care of that division before we take care of the addition. So 18 over -6 is a -3. What you're adding to 4, a -3 plus 4 leaves us with a positive 1. Number 3, everything is on the same line here. We've got no parentheses, but remember with the order of operations, we've got to take care of multiplication before we take care of our addition. So I've got a multiplication here with the 5 times 4, and this 2 and 5 is stuck together by multiplication as well. So I've got to take care of those two groups before I can start adding and subtracting stuff together. So 5 times 4 is a 20. I'm left with the plus sign, and then 5 times 2 is 10. And then this -5 versus -5 is tacked on at the end. Now we have, you know, the same level of addition and subtraction. Now we work left to right. So 20 plus 10 is a 30. 30 minus 5 takes us to 25. Cool. And number 4, looks like we've got an exponent. So, you know, first we need to take care of our parentheses, then we take care of our exponents with our no parentheses. We're going to take care of that first, but 1 to the 3rd, you know, that's just going to stay at a 1, right? So now we have subtraction, addition, and addition, so we're just going to work left to right. 4 minus 2 is 2. 2 plus 1 is 3. 3 plus 1 is our 4. All right, so the same kind of concept going on here with 5, 6, 7, and 8, but the only difference now is we have to evaluate. So we have to substitute values into our variables, right? So biggest thing when we're substituting, we're replacing a variable with a value. You need to remember to use parentheses. Okay, if you don't use your parentheses, you kind of leave yourself susceptible to kind of for errors. Also, you know, the better you are able to write it with parentheses, the easier it is to kind of throw in your calculator as well. Okay, so if you look at number 5, instead of saying x, I'm going to say 3. Right, I'm going to substitute that value of 3 in there. I have minus 3 parentheses z minus z. Well, if we're combining like terms, I mean z minus z is 0. Or you want to think of it as, instead of z's, 6's. 6 minus 6 is also 0. So if I look at this, similar to what we just did with 1, 2, 3, and 4, now we've got to simplify this down to a single number. 6 minus 6 is 0. Well, anything times 0 is a 0, so you're just left with this 3 there. Okay, so we can quickly simplify that guy. Number 6, same situation here. I'm going to substitute my numbers into my variables. So I have a q. So I have this big parenthesis on the outside. I'm going to substitute that 6 in for my q. And I'm adding m squared. Well, my m has a value of 2. oops, sorry, and that's a squared. And we're going to divide all of that, looks like, by a 2. All right, so again, being able to simplify following your order of operations, we have 2 squared there, which is 4. 4 plus 6 is 10. So now all of that junk inside parentheses takes us down to a 10. And we're going to divide that by 2. 10 divided by 2 is 5. Number 7. Again, first thing you got to do, we've got to replace all those variables with our number. P is a 5 minus 6 minus another P, which is a 5. Closing our parentheses, minus N, which is a 1. Now, I don't think, it didn't come up in any of these examples, but it may on your test. The big part of, using your parentheses, a lot of that applies to when you're using, when you're dealing with negative values. So all of these examples have a positive. I wish one of them had a negative so I could show you. But like if that was a -1, I would have to put a -1 in parentheses here. So what that's going to create, you're going to have a double sign. You would have a minus, a negative. Okay, so if you don't use parentheses, maybe you don't see that as easily, or you see this minus as a negative. Okay, that's a very common mistake, one that you really need to pay attention to. So remember when you're evaluating, if you always remember to use parentheses, you're not going to kind of get caught up in that anyway. So, but really make sure you pay attention and do that when you are using negative values. All right, so we've got to simplify this guy. We've got parentheses here. Right in the middle of our expression, so we've got to collect that a little bit. So I have 6 minus 5 inside parentheses, so I'm just going to rewrite what I've got here. I've got a 5 minus, inside the parentheses there was a 1, right? We have the 6 minus 5 minus 1. So again, we're all on the same level of addition and subtraction, so we're just going to read this left to right. 5 minus 1 is 4, 4 minus 1 is a 3. And one more here. We have all of this in parentheses. We have 2 plus q, which is a 1. All of that being squared minus m, which m is now a value of 2. Notice I'm using my parentheses. 2 plus 1 is 3, right? So now we have 3 squared minus the 2. 3 squared is 9. 9 minus 2. Oh, I'm so sorry. So all I did was combine this 2 plus 1 to say 3. So now 3 squared is 9. 9 minus 2 is 7. Sorry. Adding and subtracting fractions. I am going to do number 9 and number 12 instead of doing the whole thing all the time. Okay. So now notice that we've got a mixed number and a mixed fraction and an improper fraction. I would rather deal with improper fractions, so what I'm going to do is I'm going to change this mix into an improper. So 3 times 5 is 15. 15 plus 3 is 18. So this is the same thing as saying negative 18 over 5 minus a negative 3 over 2. Okay, so notice our denominators are 5 and 2. We need to find the LCM of 5 and 2 to find a common denominator. A nice denominator we could use here is 10. 5 and 2 both go into the number 10. So one thing I like to do, and I still do this to this day when I'm adding subtracting fractions, I know the common denominator has to be a 10. So I'm going to go ahead and set myself up, okay? So we've got a negative in this fraction and a negative in this fraction. So now I've just got to figure out what our numerator turns out to be. Well, the denominator was a 5. It turned into a 10. Well, it looks like we said 5 times 2. So what we do to the denominator, we need to do to the numerator. So 5 times 2 takes a 10. 18 times 2 is a 36. Same thing with this second fraction. Well, we went from a denominator of 2 to 10, which means we multiplied by 5. I need to multiply the numerator by 5 as well. 5 times 3 is 15. Cool, and now our answer, when we add and subtract fractions, the denominator is going to stay the same, so the 10 is going to stay down there. I have a negative 36, and I am subtracting a negative 15. Well, when we subtract a negative, it's the same thing as adding. So then negative 36 plus 15 is going to give us a negative 21. And I was dealing with improper. I'm going to leave it as an improper. If it asks you to change it to a mix, remember, divide the top number is a negative. 10 goes into 20 twice, but that only takes us to 20. We need to get to 21, which means we have 1 out of those 10 units left. So it didn't specify, so I'm just going to leave it as improper. But if it did ask for a mixed, that's there for you as well. All right, so one more fraction there for you. Again, we've got a mixed number. I'm going to turn that into an improper. So now we have 1 plus 4 times 7 is 28. 28 plus 1 is, now I have a 29 over 7. So remember, when you're dealing with a whole number, every number is actually, we can consider a fraction. Whole numbers do have denominators. Remember, it's just saying over top of 1. So now I look at my denominators of 1 and 7. Pretty easy here. The LCM of 1 and 7 is a 7. So just like I talked about before, one thing I'm going to do to kind of help myself out is I'm going to go ahead and set myself up with those common denominators of 7. Okay, so this first fraction I went from 1 to 7 by multiplying by 7. So I'm going to do the same with the numerator, which makes sense, right? We have a whole number of 1. Well, anything divided by itself is 1. So 7 over 7, and then plus, well, we went from 7 to 7, so we didn't do anything. Okay, so we can just rewrite this fraction. And remember, we're adding subtracting fractions. That denominator is going to stay. We're going to add the numerator straight across. 29 plus 7 is a 36. All right, going from and finding percentages of numbers. I'm going to do a couple of these examples with you here. So number 13, what is 90% of 52.8? When we're trying to find the percent of a number, all we need to do is multiply the two numbers together. So 52.8. Now, it would be nice if our calculator had a percent button, but when we're talking about a percent, that's not a real number. It's a percent of something, right? So in order to write the percent of a number, we need to change the the percent into a decimal. Anytime we're dealing with this, right? So even a percent, even though it's not a decimal, it still has a decimal place to it. Like I could say 90.00%. It's still the same percent, but we don't write all the decimal spots. But turning a percent into a decimal, we're going to move 2 spots to the left. Okay, and we'll work the other way, going from a number to a percent, right? So if we come out with across the number 0.87, we're going to go the other way and say that's 87%. Okay, so back to this example, when I'm dealing with 90%, if I move that 2 spots to the left, it's the same thing as multiplying by 0.9. I'm going to put the 0 in so you can see a little bit better. In your calculator, 52.8 times 0.9 gives us this guy. It doesn't tell us how many spots to round. Let's just round 1 spot. So with that being a 2, that's not going to affect the 5. So this is a 47.5. So 90% of 52.8 is 47.5. And logic in numbers, what is 90%? Well, if you can only have 100% of a number, so 100% of 52.8 would be 52.8. So we're at 90%. So it should be pretty close to that 52.8. I say that because, if you do all this math and you come out with a number of like 10, right? Well, 10 is nowhere near 52.8, and sure, it's not 90% of it. So, 47 to 52, those numbers are pretty close to each other. So, our 90% probably is fairly accurate there. Okay, kind of another way to look at all these percentages. Number 14, 19 is 12% of what number? When it's addressed like this, so number 16 is the same kind of setup. What we can do, again, we can't use that percent number, so we've got to change that percent into a number. So 12% is the same thing as saying 0.12. But what all we need to do is take that 19 and divide it by the 0.12. And that's going to give us what 19 is 12% of what number. So in my calculator, if I do that 19 over 0.12, You get the 58.3 repeating. Again, let's just round 1 decimal place there. And this is, we can say approximately 158.3. Number 16 setup is exactly like that. Okay, and 15. 8 is what percent of 151? Well, you know, this is something you actually can use in class. So we want to know what percent of that is out of a total. So when you get a quiz back and, you know, you got a, I don't know, let's just say you got a 12 out of 20 on something. You know, this is in essence what it's asking you to do. 12 is what percent of 20, right? You want to know what percent you got on the test. Well, just like how it's written there, 12 over 20, right? You would add a 0.60 or a 60%, right? So this, even though it's kind of worded a little differently, it's asking the same thing. 18 is what percent of 151? So what I can do is 8 divided by 151. You got an 8 out of 151 on an assessment, okay? So in order to find that percent, 8 over 151. 0.0529. Now, this is where I kind of talked about just a little bit ago, going the other way. This is a decimal, it's wanting the percentage. Okay, so we need to turn this 0.0529 into a percent. So again, we're going to move 2 spots to the right, and we have 5.29. Well, that 9 is going to bump that 2 up to a 3. So we're going to say, I can go ahead and write that down then. So 0.0529. If I slide 2 spots to the right to turn it into a percentage, this is going to be 5 point, and like I just said, that 9 is going to take that to a 3. Cool. One more example here. I'm not going to do both. They're both pretty much the same setup. So number 17, what is the percent of change? You know, and then it state if it's an increase or a decrease. Well, if we go from 45 to 32, that's not too hard to understand that that's a decrease. So we need to know, you know, what percent change is that? Well, first we need to know, you know, the actual number of what it decreased by, right? So we were at 45, then we went down to 32, okay?